the walls of Masada, the fortifications of Carthage, the gates of Jerusalem. Ancient Rome didn't just march across the world with legions, they brought the engineering genius to tear down anything standing in their way. From portable bolt throwers to massive siege towers, Roman siege engines transformed warfare into a science of demolition. These weren't just weapons. They were the instruments that made empires fall. This is every Roman siege engine that crushed the ancient world's greatest fortresses. Artillery engines. Let's begin with the artillery that made Roman siegecraft legendary. Ballista, the ancient world's precision sniper rifle. This torsion-powered crossbow could hurl bolts weighing up to 3 pounds with devastating accuracy at ranges exceeding 400 yards. Each legion typically deployed 10 of these machines, crewed by trained specialists called ballistari. The ballista's twisted rope bundles, made from animal sinew or human hair, generated enormous torsion energy. Against enemy walls, they targeted defenders on battlements. Against massed formations, they created bloody lanes through packed ranks. The larger versions mounted on fortifications could pierce multiple armored men with a single shot. Scorpio, the lighter, deadlier cousin, also called the Scorpion for its tail-like firing mechanism. This man-portable bolt thrower revolutionized Roman battlefield tactics. Weighing just 120 pounds, a 4-man crew could deploy it rapidly wherever needed. It fired iron-tipped bolts that could penetrate shields and armor at 200 yards. Julius Caesar deployed these extensively during the Gallic Wars, using them to suppress defenders during assaults. The psychological impact rivaled the physical damage. Enemies learned to fear the distinctive crack of its release mechanism. By the late Empire, every century carried at least one Scorpio as standard equipment. Polybolos, the ancient world's machine gun. This revolutionary repeating ballista featured a chain-drive magazine system holding multiple bolts. One operator turned a windlass while another aimed. The result devastated massed infantry formations. Though expensive and complex to maintain, wealthy commanders prized them for their rapid-fire capability. Historical accounts describe them loosing 11 bolts per minute. Few examples existed compared to standard ballistae. Their complexity meant frequent mechanical failures in campaign conditions. Still, when they worked, they were absolutely fearsome. Carroballista, mobility meets firepower. The Romans mounted standard ballistae on reinforced carts pulled by mules, creating the ancient equivalent of mobile artillery. This innovation allowed commanders to reposition fire support rapidly during sieges and field battles. Trajan's column depicts these weapons supporting infantry advances. The cart design included storage for ammunition and maintenance tools. 2 ballistarii operated the weapon, while drivers controlled the mules. During Trajan's Dacian campaigns, these mobile platforms proved invaluable in mountainous terrain where traditional siege engines struggled. Stonethrowers. The heavy artillery that pulverized fortifications. Onager, the mule that kicked like hell. Named for the wild donkey's devastating rear kick, this single-armed torsion catapult became Rome's premier wall breaker. It hurled stones weighing 50 to 90 pounds in high arcs that smashed down onto fortifications. The throwing arm sat in a massive twisted rope bundle. When released, it whipped forward violently before slamming into a padded crossbeam. That distinctive thump could be heard across battlefields. Skilled crews achieved remarkable accuracy after ranging shots. At the siege of Masada, Roman onagers systematically reduced the fortress walls over months of relentless bombardment. Ballista Lithobolos, the stone-throwing variant. While standard ballistae fired bolts, the Lithobolos modification launched rounded stones using 2 vertical arms. These proved especially effective against wooden fortifications and siege equipment. The flat trajectory delivered devastating kinetic impact at the point of strike. Roman engineers could adjust the torsion to vary range and striking power. During urban sieges, they targeted specific structures, temples, granaries, headquarters, creating panic among defenders. The psychological warfare aspect was deliberate and calculated. Trebuchet, actually a medieval myth for Rome. Despite popular belief, Romans never used counterweight trebuchet siege engines. That innovation emerged in China during the 4th century and reached medieval Europe centuries after Rome's fall. Roman artillery relied exclusively on torsion power, not counterweights. This misconception persists in films and games, but historical evidence proves Romans never developed or encountered this technology. Their torsion engines proved more than adequate for siege requirements. Battering equipment. Next on the list, the tools that broke through the strongest gates and walls. Aries, the ram that smashed empires. This massive tree trunk capped with an iron ram's head hung from chains inside a mobile shelter. Teams of legionaries swung it rhythmically, building momentum until each strike delivered tons of force against gates, walls, or doors. The protective housing featured sloped roofs covered with fresh animal hides soaked in water or vinegar to resist fire arrows. At Jotapata, the Jewish defenders poured boiling oil and dropped massive stones, but Roman rams never stopped their methodical pounding. The repetitive boom 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 became the soundtrack of Roman conquest. Some rams stretched over 100 feet long and required 60 men to operate. Tolleno, the ram that struck from above. This ingenious variation mounted a ram on a long, pivoting beam balanced like a seesaw. Legionaries pulled down one end, raising the ram high. When released, gravity accelerated the iron head downward onto wall tops, smashing battlements and defensive positions. This vertical attack angle proved devastating against parapet defenses. Defenders couldn't easily counter it like horizontal rams. The Tolleno required less manpower than traditional rams while delivering comparable striking force. Roman engineers deployed them when conventional rams couldn't reach elevated targets. Falx Muralis, the wall hook that pulled down fortifications. This massive iron hook attached to long chains operated by winches or manual teams. Engineers would hook onto wall sections, particularly near gates or corners where structural weakness existed. Then dozens of legionaries pulled in the coordinated rhythm. The mechanical advantage of pulleys multiplied their force tremendously. When walls had been weakened by bombardment, the Falx Muralis finished the job, literally ripping fortifications apart. At the siege of Avaricum, Caesar's forces used these to tear down sections of wooden palisades, creating entry points for the assault. Siege towers, the massive structures that brought Roman steel over any wall. Helepolis, the city-taker that towered above all. These mobile siege towers stood as tall as 9 stories when facing the highest walls. Built from massive timbers, they rolled forward on wheels or logs, carrying multiple levels of assault troops. The exterior featured iron plates and fire-resistant hides. Drawbridges on each level dropped onto wall tops, releasing waves of legionaries directly onto battlements. Construction could take weeks and required entire forests worth of lumber. At the siege of Jerusalem, the Romans built 3 massive towers, each requiring thousands of men to push across leveled ground. The psychological impact was immense. Defenders watched their doom approaching day by day, growing larger and more inevitable. Sambuca, the musical name for a scaling horror. This specialized siege ladder, mounted on a ship or wheeled base, could extend to incredible heights. Named for its resemblance to a triangular musical instrument, it featured a protected climbing platform. Roman naval forces used ship-mounted versions during coastal sieges. The platform at the top held a dozen armed legionaries who would secure the wall top before their comrades climbed behind them. At Syracuse, despite Archimedes' defensive innovations, Roman Sambuciu eventually contributed to the city's fall. The design's instability made it dangerous. Several recorded incidents involved catastrophic collapses, killing entire assault teams. Mining and undermining. These engineering brought walls down from below. Cuniculus, the tunnel that made walls fall like magic. Roman siege engineers were masters of military mining, digging tunnels beneath enemy fortifications. They excavated chambers directly under walls or towers, supporting the earth above with timber props. Once positioned, they packed the chamber with combustible materials, wood, straw, pig fat. When ignited, the props burned away. The unsupported earth collapsed. The wall above came crashing down. At Ambracia, Roman miners and defenders actually fought underground battles when counter-tunnels intersected. The psychological warfare was exquisite. Defenders never knew when the ground beneath them might suddenly vanish. Mining operations could take months, but success was virtually guaranteed. Musculus, the protective shed that enabled the diggers. Also called the Testudo shed, these mobile shelters allowed miners to approach walls safely. Built low and heavily armored with iron plates and wet hides, they resisted arrows, stones, and fire. Engineers worked beneath them, beginning their tunnels right at the wall's foundation. The Musculus featured reinforced roofs capable of withstanding dropped stones weighing hundreds of pounds. Multiple units could connect, forming a protected corridor from Roman lines to the wall. Defenders tried everything to stop them: boiling oil, fire, countermining. But once established, the Musculus was nearly impossible to dislodge. Defensive siege tactics. These were formations and techniques that made sieges possible. Testudo formation, the tortoise shell of shields. While not a siege engine itself, this infantry formation was essential for siege assaults. Legionaries overlapped shields above and around the unit, creating an armored box that arrows and projectiles couldn't penetrate. Entire sentries advanced under Testudo, toward walls, gates, or siege equipment. The formation allowed Romans to approach fortifications despite withering defensive fire. At the siege of Cremona, Testudo formations advanced through streets filled with defenders, shields deflecting everything thrown at them. The tactic required perfect discipline and coordination. When executed properly, it rendered legionaries nearly invulnerable to ranged attacks. Vineae, the covered corridors of safety. These were movable sheds with sloped roofs that protected troops advancing toward walls. Built in modular sections, engineers could connect dozens of Vineae, creating long protected passageways. Troops, equipment, and supplies moved safely beneath them, despite enemy fire from above. The name came from their resemblance to covered grape arbors in Roman vineyards. Construction was simple: timber frames covered with wicker, hides, or wooden planks. They proved especially valuable during the approach phase when Romans established positions near walls. At Alesia, Caesar's forces built extensive Vineae networks that allowed safe movement throughout the siege works. Pluteus, the portable wall that moved with the legions. These large wickerwork screens mounted on wheels provided mobile cover for advancing troops and siege crews. Ballistarii operated behind them. Engineers assembled rams under their protection. Assault troops gathered safely before charges. The wicker construction was lightweight enough for rapid repositioning, but sturdy enough to stop arrows. Some featured iron reinforcement plates at vulnerable points. During the Jewish wars, Roman forces deployed hundreds of plutei, creating mobile fortifications that gradually tightened around besieged cities. Defenders quickly learned these screens heralded the beginning of serious assault preparations. Specialized siege equipments. Next up, the unique tools that solve specific siege challenges. Corvus, the naval siege weapon that conquered at sea. This spiked boarding bridge mounted on warship prows revolutionized Roman naval warfare during the Punic Wars. When dropped onto enemy vessels, the spike pierced the deck, locking ships together. Legionaries then crossed and fought as if on land, Rome's decisive advantage. While primarily naval equipment, coastal sieges saw Corvus bridges used to board beached ships or reach harbor fortifications. The innovation demonstrated Rome's genius for adapting siege principles across different combat environments. After mastering Mediterranean naval tactics, the Corvus became less common, but its impact on Rome's rise to dominance was incalculable. Tollenones, the defensive cranes that grabbed attackers. While primarily defensive weapons used by besieged cities, Romans encountered and eventually adopted them. These cranes featured massive hooks or grappling devices. When siege towers or rams approached, operators swung the arm out, hooked the equipment, and either lifted it away from walls or dropped it to destruction. Syracuse's Archimedes made these infamous during the Second Punic War. Roman engineers studied captured examples and improved the design. Later, Roman fortifications sometimes incorporated Tollenones as defensive measures. The recognition of enemy innovation and willingness to adopt it exemplified Roman military pragmatism. Scalae, the humble ladder that often succeeded where engines failed. Never underestimate the assault ladder's role in Roman siegecraft. These simple tools, wooden ladders reinforced with iron brackets, allowed rapid escalade attacks when opportunities arose. Romans carried hundreds to every siege. During night assaults or when defenders were distracted, ladders enabled small units to scale walls quickly. At Numantia, coordinated ladder assaults from multiple points overwhelmed defenders. The simplicity was strategic. Ladders required no setup time, no specialized crews, no complex maintenance. When elaborate siege engines softened defenses, simple ladders delivered the killing blow. Success required courage more than engineering, and Roman legionaries possessed that in abundance. Siege support systems. Finally, let's have a look at the logistics that enabled prolonged siege operations. Agger, the earthen ramp that reached any height. Romans built massive earthwork ramps against besieged fortifications, creating gradual approaches for siege towers and troops. These engineering marvels could take months to construct, requiring thousands of workers and cavalry escorts protecting the builders. At Masada, the Roman ramp still stands today, a stone and earth structure rising over 300 feet. Defenders watched helplessly as the ramp grew daily, knowing their fate approached with its completion. The psychological impact was devastating. Some cities surrendered rather than watch the inexorable ramp construction. Once completed, nothing could stop the assault that followed. Circumvallation, the walls that imprisoned cities. Romans built fortified walls completely surrounding besieged locations, preventing escape or resupply. These weren't simple barriers. They were sophisticated military architecture featuring palisades, ditches, towers, and guard posts. At Alesia, Caesar constructed 11 miles of circumvallation facing inward toward the Gallic stronghold. Then, incredibly, he built 13 miles of contravallation facing outward against relief forces. The resulting double siege line starved both the besieged and their would-be rescuers. This required enormous labor and resources, but guaranteed success. Once circumvallation was complete, surrender became inevitable. Only the timeline remained uncertain. Cippi and Lilia, the hidden defenses that protected siege works. Romans defended their siege camps with sophisticated obstacle systems. Cippi were sharpened stakes planted at angles to impede cavalry charges. Lilia were concealed pits containing upward-pointing stakes, covered with brush to hide them. These surrounded Roman siege works, creating killing zones for any relief force or sortie attempting to disrupt operations. At Alesia, these defenses devastated Gallic relief cavalry attempting to break Caesar's lines. The systematic use of defensive obstacles allowed relatively small Roman forces to maintain sieges against numerically superior opponents. Engineering genius protected the engineers. From precision artillery to massive siege towers, from underground mining to sophisticated obstacle systems, Roman siege engineering represented the pinnacle of ancient military science. These weren't just weapons, they were the systematic application of engineering genius to the problem of fortifications. Each technique refined over centuries of conquest. Each machine a testament to Roman determination that no wall, no matter how strong, would stop the legions. Which siege engine impressed you most? Let me know in the comments below.